This week's homework concerns sorting, so you're going to want to read the second chapter of the textbook. You can skip the sections on merge sort and quick sort. You'll see those algorithms when you get to CSE 321 or 421, the algorithms class. It's important to do a few paper exercises with sorting, so I'm going to ask you to do some problems from the textbook, which are listed here. Be sure to do the starred ones, and we'll talk about the solutions in class. In addition, there's a programming assignment. In this homework, you're going to implement your own elementary sorting algorithm. To make it interesting, we're going to sort a deck of cards, and I'm going to constrain the way that you can actually access the deck of cards. What we're going to do is simply be able to look at the top two cards and compare them. That's top greater than next. We're going to be able to swap the top two cards, and we're going to be able to move the top card down to the bottom. So that's all you're supposed to do with this deck of cards. I'm giving you a few extra operations here. One is an operation that will tell you the size of the deck of the cards, count the number of operations that have been performed on this deck of cards, and also to determine whether or not the deck of cards is sorted. So using this, you should be able to write a sorting algorithm. The way to do this is to think about the problem a little bit and then type in your code. So I've given you some hints if you want to look at those. You can also wait. You can just stop this video now, go do the homework, come back if you get stuck. The solution here is to loop through this deck of cards. So if you can actually do this physically, take just a few cards, like 3 or 4, 4 is a good number, and shuffle them, and then try and sort them using this technique. And you'll see that you can do a couple of things. So one thing is you can just go through all the cards and get them back, in the same order they were. And you have to count here. So you just count the number of cards. You know that up front. You know there's, say, 4 cards or 52 or whatever it is. And you can just move one top to the bottom, and you know that you've got the deck that you started with. Of course, you can do this a nested number of times. So if you want to move through the deck n times, this would be an n squared algorithm. And in fact, that's what you're going to end up doing for this homework. The only way to do this is n squared time, given what I've given you, the capabilities that you have. And if you want, you can actually, do different things at different points. So let's say for some number of iterations, I'll just do one thing, and then for some number of iterations, I'll do something else. You can play around with different combinations of this. Here's some little bit of code to sort of just get you started. You can copy this and just paste it into Eclipse and see what it does. So the program that you've got to start off with is just going to throw an exception, and you can look to see what's happening here. I've got a main method, which is starting with a deck of size 10, and it's just trying to run the sorting algorithm on that. So it's doing this through a countops method. The countops operation starts a stopwatch, counts how much time it took, and then checks to see if it's sorted or not. The isSorted method here is going to throw an exception if the deck is not sorted. And you can see that's exactly what's happening here. The deck is not sorted, so we're mad. So how do you get this to work? Well, you need to fix the sorting algorithm. And we can get some intermediate progress just by trying something like this. So this isn't exactly correct, but you can get some sort of sense of what's going on. And it's definitely helpful to print initially. Let's just try going through the array and printing every time we go around. And you can see if I start with an array of size 10, well, I'm easily confused. So let's start with an array of size 4, which is a little bit more manageable, and walk through that. And you can see what's happening is just a rotation. So you can see 3 is just moving over 1, and 1 wraps around. It's just sort of a wrapping around rotation as the cards rotate through this deck. That's what you'd expect. Of course, you can do something vaguely interesting at each point. So for example, here, if I have the 2 cards at the top out of order, I can swap them, and let's just try that and see what it does. And you can see here, it sort of fixes one of these cards in some place. Maybe not the right place, but it's some place. And that's sort of a hint as to how to make progress here. I've actually gone through the array just once. And if you go through the array once, you'll get pretty much one card in place. And so to get n cards in place, I'll have to go through it n times.